This is a secret mitre dovetail joint. Granted, it's not much to look at, but it is a very, very strong joint. It is used in situations where you want the grain from this board here to wrap around the edge and go onto the other board without any of the joinery showing. The joint is made using dovetails, and if you would like to learn more about how to make those, you can see that in a previous video, which I'll link above. But inside the joint, there is a set of pins and a set of tails, just like in a regular dovetail. And they mesh together to provide a very, very strong joint. As can be seen here, you've got your tails and these are your pins. So we're going to model this today. Now I've already set up a pin board and a tail board, so we'll just get straight into it. To simplify things for this demonstration, I created a couple of models that contain spreadsheets in them. Spreadsheets just simply have the same information and define the board and the pins and tails. So we've just got the length, width, thickness, lap. This is the distance from the edge of the board to where the pins and the tail start, the half pin width, the full width, and the length of the joint. So we'll switch over to the part design workbench. We'll work on the pins first. So we'll create a sketch in the XY plane. And it's, for starters, it's going to be a rectangle that is symmetrical around the origin. In fact, there's two ways you can do that. You can either do it as I've just done by putting two lots of constraints, one across the width, one across the height, or what we can also do is we can simply just pick top left, bottom right, and the center point and do the same thing. It's quicker, probably quicker that way. Now we've got 4 degrees of freedom, okay, because we're missing a couple of constraints. So we'll just put those ones in. So this needs to be vertical, and this is a horizontal constraint, and then we'll set the length and the height. Now these come straight out of the spreadsheet. So one is length. Whilst I've been saying height, in this case it's actually the width of the board. So we'll set that as well. Width. Fit, and then we'll just pad it out to be the thickness specified in the spreadsheet. There we go. Now the design of both the pins and the tails are the same up to a certain point, and we're just going to repeat them in both cases. Typically you might choose to start with the pins, and when you got to the point where you have to deviate to do the different bits of the design, you would save it as a second copy. In this case I'm just going to do both. It's not a big deal. So what we're going to do is we're going to make a space for the lap. So we create a sketch on one of the long faces, and we bring in some external geometry, and we're going to use a polyline. And what we're going to do is simply just going to make a 45-degree cutout which represents the lap. That is vertical, and this angle here is, we're going to set that as a 45-degree angle. And got 1 degree of freedom missing, which means, and that that length there, that is actually the length of the lap, which is in the spreadsheet. So we set that in, that's lap. And we're fully constrained. And then we just cut it off. Now that we've got the lap, we need to look at what else we need to do. So if I jump back to the assembly and just show you the pin board, you can see that there is a full length mitre here, which we need to put in place first. So we'll do that. We click on this edge and we're just going to create a sketch there. We will bring in some external geometry so we can work with it. This one's a relatively easy one because it's simply just isosceles triangle. That's horizontal, and the length of these guys are equal, which will make it, once I've got all the points together, which will make it a fully constrained triangle. What we're going to do is we're just going to make that a 5mm cutout, just like we have with the lap, and then we're going to mirror it on the other side. Rename that to mitre. There it is there. Okay, so normal sketch axis, reverse the direction, and it is spreadsheet.width minus the 5 millimeters from the other. Edge, which puts it right into the place that I want it. Alright, now if we jump back to the pin board in the reference assembly, we'll see that we've got to now start modeling the pins, or the cutouts for the pins. So we create a sketch on this face, bring in the reference geometry, that one, and that one. Oh, and one more, and that one. So we're going to model one of the pin sockets here, and then we're going to use a linear transformation to make the rest. So we're just going to create a polyline which represents the pin. Okay, cool. So the angle between here and here, we're just going to make 105 degrees. And same on the other side. 5 degrees. And then we have 2 degrees of freedom apparently. So we'll set the width of the pin to be the half pin width, which is in the spreadsheet. Sorry, the full pin width, which is in the spreadsheet. Now we have 1 degree of freedom, and that is the distance from the end. Why is my computer playing up? Quickly close that, jump back in. And so we're going to go from here to here, and that is the half pin width. now we have a fully defined sketch, and we are going to not pad that out. We are going to create a pocket. Joint length. Call that pin. And then we're going to do a linear transformation. We want 5 of them. And the spreadsheet, the distance that we want is the spreadsheet dot width minus 2 times the spreadsheet times the half pin width minus 10 for the 2 miters. 1, 2, 3, 4, 5, and that hasn't quite got it right, has it? So maybe it's just minus the miters, because the half pin width. Maybe spreadsheet dot full pin width. Okay, that's better. 1, 2, 3, 4, 5. Okay. Where I went wrong in this one is I forgot about having to take off the first pin as well. So that gives us our pin board all ready and done. So what we're going to do is jump across and do a similar sort of thing in the tailboard. So we've got the body in place, so we'll create a new sketch on the XY plane. Just going to put a body around it and make it symmetrical to the center line. The width of it is defined in the spreadsheet. Same with the height, the length. And we pad that out as before to this thickness. Okay. It's now time to do the lap. So we create a sketch. Yeah, it's fairly easy to do this one. It's really just repeating what we did last time. Width of that bit is the lap as in defined in a spreadsheet. And the angle here is just 45. We then create a pocket the whole way through. Call that the lap. And then what we're going to do is we put the mitre edges on. So again, we create a sketch on the same face. Sketch on the same face. bring in our geometry. These guys are equal, and oops, we didn't quite get that joint right. Close that up, and we make a pocket of 5 mil. Mitre, and then we're going to mirror that to the other side. On the normal sketch, it's reversed, and width -5, and okay. So now we're going to do the tails. Create a sketch on this one. And we're going to remove everything that we don't want. So first up we'll do the half pins. That one's a vertical, and it is the half pin width as defined in the spreadsheet. Now it's easy to get these turned around, so we will have to check them once we put the assembly together. And we're going to cut a pocket out of that, and it is going to be the joint length. And then half pin, and then we're just going to use the linear feature to get rid of the other one. Vertical sketch, that's right. And it is going to be minus spreadsheet width minus the mitre, I think. See how that one goes. Oh, too far. Alright, so what it means is we then also need to remove the half pin width as well. Should remember that from last time. 2 times the width, 2 times the miters. There we go. Ooh. And it's not a, it's a mirror, you idiot. Not a, cancel that. It is, we're going to add a mirror. Mirrored on the, there we go, on the vertical axis. That gives it, that makes it so much easier. Now we'll do the other pins. Remove the other pins, I should say. So we bring in that and that. Again, we do a polyline. That one there, the base of it is the spreadsheet dot full pin width, and this angle here is 105 because we want it going out, and we've got 1 degree of freedom in here somewhere. Okay, so we've got these 2 points not coincident and joined, so now they are. Oh, we went the wrong way. Sometimes it happens. I'm an idiot. So we'll get rid of these. I need need to bring that one back in again, because as I said, it can be quite easy to get these things turned around if you're not concentrating as much as you should be, especially when you're thinking in terms of pins and tails, and forgetting that you're actually doing taking away the waste, not keeping the bits you want to keep, which is how you would, sort of do it when laying it out. You would do when you're laying out the tails, you measure out the tails and then cut away the waste. In this case, we're sketching the waste to cut away. So sometimes I find it easy to get my head turned around and not think, and get them and do the pins when I'm supposed to be doing the tails, and vice versa. Okay, so from there to there is the full pin width. Actually, no. This one I think we're going to struggle a bit. That's the full pin width. No, in actual fact, the full pin width is actually on the front. Put a vertical constraint in there to make them the same. Now we're just moving here. So I've got a funny feeling we might just have to might have to sketch all the bits. Might be just as quick. That vertical, that, and that are all equal. That, and that. Oops, these are not joined. Let's fix that. These guys are all parallel, and so are these guys. Alright, so I'll switch over. Hang on before we do that. Let's quickly check. Go back to turn off our pins, come back to our reference, and we'll see that we've got 5 tails. So I need to put another one in somewhere. Constrain that to be vertical. Again, also make these guys all. Probably doesn't matter because I'm going to stick some construction lines in a moment just to help finish it off. Parallel, that and that. Parallel, that one is vertical. that and that are equal. So now we'll click the construction lines in just so we can that one's vertical, that one's vertical, that one's vertical. Put those together and put those together. And that one too is vertical. So we've got 5 degrees of freedom now. What's going on here? Okay, so they're all moving, right? Da, da, da. These guys are all equal as well, except that one. Equal. That and that. They're all equal to. Right. And we're just going to punch those out, and that's going to be joint length. One, two, three, 4, 5. Okay, so now what we'll do is we'll create an assembly and try and put this thing together. So we'll switch over to the A2 Plus workbench. Oops, forgot to save it. And we will add the pins, pin board, and we will add the tail board. And what we'll do is we will rotate the tail board, transform the tail board so that it is in the right orientation for where I want it to go. We'll just zoom in a bit and we'll just try and line things up, and as we can see, we've already got a bit of a problem here. Yeah, so I've got six pins on this, or 6 tails on this side and 5 pins here. Okay, so that's okay, we can go and fix that. So jump back in the tail board, we'll go back into sketch, and what we'll do is we'll just remove one of these and reassociate all the geometry. Push that through, save it, and come back into the assembly and refresh it. And that's starting to look a bit better. And we'll finish the transformation, so we'll turn it at 90 degrees to itself. So it's vertical. Now what we're going to do is just try and constrain it together and check to see that I've got all the joinery correct. So we'll just use that main face there and this face in here, and we'll do a coincident constraint, bring it together. Oops. And obviously I'm going to struggle a little bit at the moment, but we'll see how we go. So I'm going to select this bottom face, actually make it this bottom face, and zoom in on and zoom on this bottom face and use that, doing a coincident as well, accept that. And so what we have now is that they are mostly in the right place. Zoom out a bit, but you can see it's an overhang. So what we'll do is we'll go to the back view, bit of an angle so I can see what I'm doing. I'm going to select that line there and this line here, and then we're going to do coincident line constraints, pull it all together, and now we have, oops, now we have it put together. What I don't know yet is whether I have got all my geometry right inside, so I'll switch to wireframe, and we can see that something obviously is not right. So that's the tail board, and that's the pin board. So it looks to me like the tail board is out, and again, this is what I was kind of getting at when I said you can get your head turned around. So we'll save that and we'll jump back in to the pin board, and we'll just quickly check the sketch, because what I think I've done is I've set the width of the half pin on the tail board to be here when it should have been there. Maybe it could be the other way around, but we will check. Yes, and I think I did. So let's take that one out. Let's pop that on the other side. But what that makes it interesting is that that has now changed to here. So I think I was right the first time. And we'll leave it there. Maybe what I did was did it wrong on the pin board. So we'll go back to the pin board and we'll just check that. Yeah, that one's, maybe it's this. Okay. So come back into here. What I did differently last time is I did the half pins in with the final sketch. So I wonder whether I've messed this bit up. There, that's the right spot. Okay, I know what I've done wrong. Alright, coming back to here. This one is 8mm, or the full pin width, not on the tail itself. Right, that's probably looking a bit better. Let's close that. Let's turn the pocket back on. Let's see what we've got. That's looking all right. Save that, come back into the assembly, refresh it. Okay, and we're still fractionally out, and it looks like it's the first and last tail is wrong. Not enough angle on it here. Okay, so we just jump back in there. In fact, it could actually be the pocket that's the problem. Let's go back to this one here. Yes, because that's out. It's not 85. It should be 75. Because the other ones are 105. Basic geometry, you idiot. And that fixes that. So you can see that it's not terribly difficult, but as I proved due to my own mistakes, that you can actually turn yourself around inside your head fairly easily and put things in the wrong place. Well, I hope you found that interesting, and I hope you got something out of it. If you did, please leave a comment below and consider subscribing to my channel. If you do subscribe, please click the notification bell and then you'll stay up to date with my videos. Thanks for watching.